So today in Math 10-3, we are looking at temperature conversions. This is lesson 4.1. And so we're going to be converting between Fahrenheit and Celsius. Again, Celsius is the temperature that we use in Canada. It's the one that's most commonly used, and Fahrenheit is one that is used in the States primarily. So you can see we've got three different temperatures there, three different thermometers, sorry. And those thermometers show us Celsius and Fahrenheit. And notice our blue here is at 0 degrees. And so at 0 degrees in Celsius, we're looking at 32 degrees Fahrenheit. So 32 degrees is Fahrenheit, right? And that's where we have water freezing. If we come over here, we've got a temperature that is 40, above 40, and that's hot, 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 right? And that in Fahrenheit is a little bit over, probably about 109, 110. So what we think of as really hot at 40 degrees, in the States they're looking at 110, right? Even 30 degrees. If we really want to focus here, if we look at a 30-degree day in Celsius, that's about 88 roughly. And here we're a little high for room temperature, but a nice comfortable day, and that would be 24, and over here that's about 75-ish, 74, 75 roughly. So just so you get a sense of those temperatures. Let's, one of the things we should pay attention to is important mark temperatures. So things like when water freezes. And we talked about that. In Celsius, that's at 0. And in Fahrenheit, that occurs at 32 degrees. When we have water boiling, that in Celsius is 100 degrees. And so that's actually how the Celsius degree was set. Well, if we're going to look at when water freezes and when it boils, we're going to take that difference and split it into 100 pieces. Where in Fahrenheit, and I don't know the background between it, but here in Fahrenheit we have 212 degrees. And so you can see that difference of 100 degrees in Fahrenheit is a little less than 100 degrees. So 112, so that's 100, and let's just subtract those out. Yeah, it's 180. I didn't want to make a mistake. So the difference there is 180 degrees to our 100 degrees. So each Fahrenheit degree is, or sorry, each Celsius degree is equal to 5/9 of a Fahrenheit degree. So if I look at and I throw in 180 for my Fahrenheit degree, we know that should come out to 100, because that's the same difference. Let's multiply that out on our calculator. We take 5 times 80, 180, so 5 times 180. That gives us 900, and we divide it by 9. And so we get 100 degrees. So we can do temperature differences just by this ratio, by saying we know that the Celsius degree is larger, and it's almost twice as large, but not quite. In fact, it's 9/5. So if we look at it the other way, and we go 1 Fahrenheit degree, that's 9/5 Celsius degrees. And so we have to If we substitute in our Celsius degree, we're going to take and multiply it by 9 divided by 5 to get the Fahrenheit degree. Now that's not exactly how we do the conversions, but that's when we're looking at just a temperature difference. And I have an example like that we'll come to. And one of the things, as I say, that's worth noting is going off onto the internet and looking at, say, body temperature, so you know them in the two. What would be, how hot should a oven be in the two temperatures, and do those sorts of things. Let's look at our example here. So we have Kathy visiting in Florida. She heard a local person say that it had been very cold overnight, as it was only 42 degrees. Now, we just talked, 42 degrees is really hot. It's not cold, at least in Celsius. At first, she thought this was not cold, but then Kathy realized the person meant degrees Fahrenheit. What was the temperature in degrees Celsius? Well, we need to look at how we convert. And here's two formulas. And you'll need to recognize which one to use at which time. So when you've given a Celsius temperature and you're looking for a Fahrenheit temperature, you're going to use this one, where your Fahrenheit degrees is equal to 9/5 times the Celsius measurement plus 32. When you're looking to find your Celsius measurement, you take 5/9 times the Fahrenheit minus 32. And notice I brought those 9/5 and 5/9 up before. The difference is that not only has the Fahrenheit temperature, the amount each degree is worth is different, it also has been shifted up. So think of the thermometer of a Fahrenheit thermometer being shifted up in comparison to a Celsius thermometer. And so that's what the plus and the minus of 32 degrees is. So if we're given a Fahrenheit temperature and we're looking for a Celsius, we use the second one. And that's described to you here, and that's all written out for you in your formula sheet, on your formula sheet. So you want to make sure that you're using it. So we were given 42 and in degrees Fahrenheit, and we're wanting the Celsius, so we're going to use that second formula. So let's go back to our example and we will calculate. And just edge this up a bit. So we're going to calculate a Celsius. Oops, we're calculating a Celsius degree. Our temperature in Celsius. And that's equal to 5/9 times the Fahrenheit temperature minus 32 degrees. So let's see how cold that is for us. So we have 5/9 times 42 degrees minus 38 degrees, or 32 degrees. So our degrees Celsius is 5/9 times 10. So that gives us 50 divided by 9. And 50 divided by 9 is 5.2-ish, 5.5. Let's just calculate it out. So we have 5 divided by 9, or 50 divided by 9, and that gives us actually 5.6 degrees. So when this person in Florida said it was cold, well, absolutely, 5.6 degrees is a bit chilly. So that's converting from Fahrenheit to Celsius. Let's go on to example number 2. So Stephen was paving the road with hot tar during a hot summer day. He notes that the external temperature of the tar was 48 degrees Celsius. Whew, that's pretty warm. What temperature is this in degrees Fahrenheit? So let's go back to our formulas. We'll just click back there. We've been given a Celsius temperature. So we're given a Celsius temperature. We're looking for a Fahrenheit temperature. So we're going to use this first equation. F is equal to 9/5C plus 32 degrees. So now let's click back here. And we've got our equation. We want to know what it is in degrees Fahrenheit. So we take 9 over 5, 9 over 5c plus 32 degrees. So let's substitute in. We have 9 over 5. That looks a bit better. A bit better 5 times 48 plus 32 degrees. So first, let's do the calculation. So 48 degrees Celsius. So if we have just, we don't care in terms of where it sits on the thermometer itself. We're just, how many degrees would that be in Fahrenheit? So I take 9 divided by 5, and then I multiply it by 48 degrees. So 9 divided by 5 times 48, and that gives me 86.4 degrees Fahrenheit. And so 48 degrees is that hot, but that's just 48 degrees if we think of it for us, that's from 0 up to 48, right? From our freezing temperature up to 48 would be 86 degrees Fahrenheit. But we also have to then add our 32 because what they consider freezing is at 32 degrees. So we have to add 32 degrees to that. So we take that, add our 32 degrees, and we get 118.4 degrees Fahrenheit. So really, really warm. Okay, let's look at one more example. Here in 1992, there was a Chinook that caused a temperature change of 41 degrees Celsius. How many degrees did the temperature change in Fahrenheit? Well, so now we don't care about where it sits on that. We don't have to add it up. Think of it, if we think of this, we're going from 0 to 41 degrees in Celsius. Well, what would that change be? If I started at 0 and I went 41 degrees Celsius, what would that be in Fahrenheit from freezing up, right? So we don't care the fact that we'd have to add that 32 to shift it up to freezing temperature. We're just looking at the temperature change. So in this case, we can take 1 degree Fahrenheit, and we know that each degree Celsius is larger, so to get the degree Fahrenheit, we have to take 9 divided by 5 times C. So we take 9 divided by 5, and that's multiplied by 41 degrees Celsius. When we multiply that out, 9 times 5, so let's do that on our calculator. Sorry, 9 divided by 5 times 41, and we come out with 73.8 degrees Fahrenheit. Now, this is an adaptation of a question that you're going to do in your practice. It's on page 181, number 5, and it has you calculate the low temperature and the high temperature, and do that and then see if the temperature change doesn't work out exactly right. So let's take some time, do some practice. You're going to build your skills, and on page 127 and that must be there must be typos in there. The 127 is probably 172. Just let me check. Actually, it's 177. So let me just correct that here. That's 177, 1 through 3, 178, 4 through 6, and then page 179, questions 1 through 8. And I will talk to you later. Bye now.